In this video, we'll discuss the algebra of complex numbers. The problem is to express the complex number z in the form a plus bi. This form here is usually called the rectangular form or standard form of a complex number. Let's start with z. We're going to multiply the top and the bottom by the complex conjugate of the denominator. So we'll recopy that denominator and just reverse the sign between the two terms. Our conjugate is 4 plus 7i, so we'll be multiplying top and bottom by that complex number there. I think I'll throw brackets around everything just to make sure we do our multiplication correctly. Next step would be to FOIL out the top and the bottom. So looking at the numerator, we'll have 4x plus 7xi plus 4yi plus 7yi squared. Foiling out the denominator, we've got 16 minus 49i squared. Notice that I haven't written out the inside and outside terms because these two terms here are going to cancel. We'd have a minus 28i, a plus 28i, and this will happen every time. This cancellation will happen every time we multiply a complex number by its conjugate. Next step would be to use the fact that I squared is equal to -1. So on top we've got 4x plus 7xi plus 4yi minus 7y, and in the denominator 16 plus 49. So if we continue to clean this up a little bit more, in the numerator, let's group the real terms at the beginning. So 4x minus 7y, and we'll put the imaginary terms at the end, plus 7xi plus 4yi. And in the denominator, we've got 65. So now just a final bit of cleanup to really make it look like a plus bi. Well, the real part is 4x minus 7y over 65 plus 7xi plus 4yi over 65. And for our final answer, last thing we should do is just pull out that factor of I from the numerator, and the coefficient will be 7x plus 4y over 65. And we've now expressed our original complex number z in the form a plus bi, where a and b are both real numbers.